Buckle up, cosmic explorers. This groundbreaking discovery might just rewrite our understanding of the universe's hidden mysteries, revealing a tiny, dark enigma that's got astronomers buzzing. Imagine stumbling upon a cosmic jackpot. Astronomers have shattered 2 major records all at once, thanks to a sheer stroke of luck in how celestial bodies lined up. They've captured the sharpest ever glimpse of a radio arc bent by gravity's invisible hand. And tucked within it, a subtle twist hints at the lightest gravitational mass ever spotted, pulling off this trick from billions of light years away. But here's where it gets controversial. Could this be evidence that dark matter, that elusive stuff making up most of the universe, isn't as evenly spread out as we thought? Stick around as we dive into the details, and you might find yourself questioning everything you know about the cosmos. To make sense of this, let's break it down gently for beginners. Picture spacetime not as a flat sheet, but like a stretchy trampoline. When something heavy, like a star, a black hole, or even an entire galaxy, sits on it, it dips and warps the fabric. This warping acts as a natural lens, bending and amplifying the light or radio waves from far-off objects behind it, much like how a magnifying glass enlarges tiny print. It's called gravitational lensing, and it's a powerful tool astronomers use to peer deeper into the universe, revealing things that would otherwise stay hidden. For instance, think of how a funhouse mirror distorts your reflection. That's space-time playing tricks on light. Enter JVAS B1938+666, an elliptical galaxy lounging about 6.5 billion light-years from Earth. This galactic giant is perfectly positioned to lens the light from an even more distant source, over 11 billion light-years away, right in its line of sight. The alignment is spot on. In infrared wavelengths, it forms a nearly flawless Einstein ring, a glowing circle where the lensed image loops back on itself, like a cosmic halo. In radio waves, though, it shows up as a slender arc, emanating from what scientists believe is a young supermassive black hole in a growth spurt. This black hole churns out asymmetric radio emissions, which the gravitational lens then stretches and amplifies, creating that distinctive arc. It's like nature's own amplifier, turning faint whispers into a symphony we can hear across the void. What makes this discovery record-breaking is the unparalleled resolution of the radio arc observations. They achieve this using Very Long Baseline Interferometry, VLBI, a clever technique that links radio telescopes across vast distances. By combining signals from these dishes as if they were a single enormous telescope, spanning entire continents or even oceans, they create an effective telescope as wide as the space between them. In this case, 22 telescopes joined forces, unveiling intricate details in the lensed arc, including a tiny kink that screamed intruder. This kink points to a compact, unseen mass lurking between us and the distant radio galaxy, estimated at about 1 million times the mass of our sun. And this is the part most people miss. It's not just any mass. It could be a clump of dark matter, that invisible substance we know exists because of its gravitational pull, but can't see directly. Think of it like finding a hidden iceberg in the cosmic ocean, one that might explain why galaxies form and corrupt together instead of spreading out smoothly. John McKean, an astronomer from the University of Groningen, the University of Pretoria, and the South African Radio Astronomy Observatory, put it vividly. From the first high-resolution image, we immediately observed a narrowing in the gravitational arc, which is the telltale sign that we were onto something. Only another small clump of mass between us and the distant radio galaxy could cause this. But turning raw data into this revelation wasn't a walk in the park. It required sophisticated computer modeling and new numerical methods to tease out the details, like spotting that kink amid the noise, because the data sets were massive and unprecedented. As Simona Vengetti from the Max Planck Institute for Astrophysics explained, The data are so large and complex that we had to develop new numerical approaches to model them. This was not straightforward, as it had never been done before. Devin Powell, also at the Max Planck Institute for Astrophysics, added a layer of excitement. Given the sensitivity of our data, we were expecting to find at least one dark object. So our discovery is consistent with the so-called cold dark matter theory, on which much of our understanding of how galaxies form is based. Having found one, the question now is whether we can find more, and whether their number will still agree with the models. And here's where opinions diverge wildly. Some scientists hail this as a win for cold dark matter, while skeptics argue it could point to alternative theories, like modified gravity, where dark matter isn't needed at all. Is this discovery a slam dunk for our current models, or a hint that we need to rethink the universe's building blocks? This groundbreaking work was shared in 2 detailed papers. One zooming in on the radio arc in the monthly notices of the Royal Astronomical Society, and another delving into the dark object in Nature Astronomy. It's all about pushing the boundaries of what we can observe and understand. So, what do you think? Does this tiny dark object make you more convinced of dark matter's clumpy nature? Or do you lean toward thinking there might be other explanations lurking in the shadows? Share your thoughts in the comments. Let's debate the mysteries of the cosmos together.